Welcome back. So in this lab, we are going to look to lab 1, which is basically an introduction to the IAM. Now in this particular lab, we are going to create users and a group, and then we will see how we can use those users and the group in order to control the permission to do and to access the AWS IAM service, and then to manage the access of the user to a specific services like EC2 and S3. So in the first step here, we are going to sign in to the management console using your root account. If you don't have a root account, you can create a new AWS account. From here, all you need to do is to provide your username, and this will be your email personal address, and then you will verify that email, and then you will proceed to sign in with you have to provide also your credit card. If you already have a root user account or an IAM user, this IAM user need to be with a full administrator permission in order to do the task that we need to do for this particular lab. So I'm going to use this IAM user, and this will ask me for my account ID, which is the 12 digits for my root account. So you should receive this, and you should know this if you have a root account. If not, you need to create a root account. Click on sign in. Now I am here in the AWS Management Console, and the first step I need to do is to go to the IAM service. So I could search for it from the IAM service like this, or I could go to all services and I will look to the security, because IAM is a security services. So if you look here, you will find multiple services related to multiple things, and we are interested in this management and governance. And you will find in management and governance, there is multiple services that you could use, like the AWS well-architected framework, and you need to look for example, security and identity compliance. You will find that the IAM service like this, it's located here. You could add it to your favorite, and once you add it to your favorite, it will appear in your dashboard. So you can easily find it every time you want to navigate to the IAM. So let me now go to the IAM, and from the IAM service, I need to create users. So the first thing I need to do is to add a new user. So this user is going to be called user-1. Now in this user-1, I need to activate that this user will be accessing the management console. The access key is for the people who are going to use that user to access the AWS services using the SDK and the CLI, or to send an AWS API calls. In this particular lab, we need those users to access the management console. So we are going to select password here, and we will use a custom password. Now the lab sheet is asking us to provide lab-password1. So this is the first user, and deselect now require password to reset. I'm not going to add or to save this user to my Chrome up until now. I have previous groups. I'm not going to assign them. Okay. So I'm just going to go to the tags, review, and then create user. In the next step, I need to close this page and come back here and add another user, and this user will be user-2. So this user also need management access with custom password, and will take the lab-password, and will be lab-password2. L is capital and P is capital. I don't want to regenerate a new password when the user sign in, just to make it easy for us. And I will do next, add tags, next review, create user, close this. You could send that also, that login information to your user. So if you are creating this for your employee, you will find this feature is really handy. Select password, custom password, capital L, lab-password, and will be lab-password3. Deselect user must create a new password, and now select review, create user, and then close. In the next step, I need to create a groups. So I'm going to go to the left navigation pane, and I will find there is user and there is user groups. So I'm going to create a new group. Now this group will take the name EC2 support, which means that particular group members will only be able to have a specific permission in that EC2 service. And those permissions are limited to EC2 read-only access, so they cannot delete, terminate a machine. They can view the EC2 only. Now to assign a permission to this group, we can look to the permission below here, the permission policy, and we can select or look for EC2 read only, and we just need to search. I find the pre-configured policy from Amazon, and you could expand it. You could see that this policy is giving an allow action to describe an EC2, to describe a load balancer, also to list the metrics related to CloudWatch. So they might be also very useful for those users to monitor the machine. Maybe we just need to monitor the machine by those users in that group. So I'm going to create a group, and here there is no space at the end, and then we click on create group. Next, we need to create another group, and in this group we are going to call it EC2. We are going to call this group EC2 admin, and then we have to create as well an S3 support group. So let us create now the S3 support group. So I'm going to put the name here S3 support group, no space at the end. Navigate down to the permission, and in the permission we need to give those users in this group an access to Amazon S3 read only access. Select this permission and create a group. So you can see here I have an admin group which I use for my personal business, and I have the EC2 support group and the S3 support group. Next, I need to create the EC2 admin group. Now in the EC2 admin group, we are going to give those group members a full administrator access to EC2, which means any user in that group can create, launch an EC2, terminate an EC2, restart an EC2 as well. So we are going to assign this. If you are not sure what kind of activity, we can see that EC2 star means all action in EC2s are allowed. And this is including any operation that the user in this group need to perform over EC2. Create a group now. So I have 3 groups. Now next, what we need to do, we need to add those users to group, and we will start to experience signing and signing out in this particular group. So let us add now user 1. Let's go back to the user group from the left navigation pane, and we choose the S3 support group, and then we will click here on add user. We want to select user 1, and we will add this user to our group. Then we need to go back, and we need to select the EC2 support group, and then we add user, and we will select user 2. And finally, we need to go to the EC2 admin group, select it, add user, and then we will select and add user 3 to this group. So now all my users are assigned to a group. So let us now test their permission. So let us go back to users, and we will select user 1. So in user 1, once I go and select that user, I will be able to get the permission of it, and how I can get the access, or how I can sign in using this group user into the AWS Management Console. Remember, we assign this user 1 to the Management Console, so he is allowed to sign in. So we need to go to the dashboard. In the dashboard, we will find that this AWS account, this ID, is basically giving this sign-in user sign-in URL for all IAM users. So I need to copy this code, and I need to open incognito window. I will paste it. Now this will ask me now to basically put the user that I want to log in. So I'm going to put user 1, and in user 1 now, I need to put the password, which is lab-password1. And sign in. So it is going to be lab capital P password 1. So I am now signed in. Now the lab sheet is asking me now to navigate to S3, and from S3 I want to verify that I can, if there is any existing bucket, I will be able to view them. Now I have a bucket here for my Solana Cafe website, but I can look at it, as you can see, and I can view it. Maybe in your case, you won't be able to see this. So what we are going to do now, we will try to launch a bucket, and let us call this bucket a demo and the date of today. The easiest way to create that. So it will be 14th, 04 April, and this will be 2022. And let us see if we can just create this bucket using this user. And you can see now, this is give us a permission error. So we are not allowed to create a bucket. Now, if we go to our EC2s, in our EC2 instances in North Virginia, you can see I'm getting all these error here in the dashboard because I have read-only access to SC3. I have no permission to launch an instance in the management console. So if I click here launch and I create like test, just to show you guys, and create a key pair, I'm not authorized. Even if you switch to the old console and you try to launch an EC2, you can't perform this action because you don't have permission to do so. So let us close this now, and we need to go back to our basically admin user. So keep this in your mind. Copy the sign-in again, and then open a new private session. Even if you want, you can try this from another browser. So all you need to do is just make sure you are not in the same browser because you already logged in to this browser with the admin user. So this is all you need to do. If you do so, you might just get the same error and you will be signed out from your admin user. So be careful about that. So we will go back to IAM now, and let me go to my private session and let me sign in now using user 2. In user 2, the password was capital L lab, capital P password, and this is 2. And let me sign in. Remember, this user has a permission to basically go to our EC2 instances. So we need to go now and see if there is any EC2 instance created for us here. Most likely you will find this page is empty. So all I need you to see that yes, you can view an existing EC2 instances, but you can't create one because you have a read-only permission. So even if you do everything here in the launch configuration, you will start to get multiple error. Once it's come to launch, the process will fail because you are not authorized to perform this. But which user is allowed to perform this step? If you close this page now, go back to the sign-in, open a new private session, and sign in using user 3, you will be able to launch an EC2 instance. So this will be user-3 lab-password is 3 and sign in. Go now to your EC2 instance and try to launch a new EC2 instance. You will find that this user is able, because he has a full administrator access, to launch an EC2 instance. I prefer to use the old console because it's much easier for training and learning. If you're happy to use maybe different format, it's up to you. So I am okay now. I can launch an EC2 and I just select the default, guys. So I keep it in the default VPC. I keep it just with the default setting. So I can view this instance now. I can basically do whatever I want with it. I can stop it, terminate it. All of these actions are valid. I will keep this page now to show you, and I will open a new private session and I will start to sign in using my user 3. So if I go to user 3 now, user 2, and remember user 2 is in the EC2 read only. So this is lab password 2, capital L dash capital P. If you go to the EC2s now, you will be able to view the instance. All the information about this EC2 is available to us. You could go to the monitoring and you see you have a limited access to CloudWatch. You don't have full access. You could check the status, could check the details. But can you, for example, from the action menu, do like the instance state, can you stop the instance? If you click here in stop, you will get an error message. If you navigate back to your user 3, so let us go to user-3, with lab password 3, you can see that I have full permission. I can get all the details I want in CloudWatch. I could also simply reboot this machine. I could stop it. I could do whatever I want. So this is what I want you to see in this first lab, which is an introduction to IAM. So you are given a task to build a VPC, and there is many ways now. There is 2 different ways to build a VPC with the new console and with the old console. So if you are seeing similar page to this one, then you are definitely using the new update of the AWS Management Console. So to build a VPC, which is the first task, is to go to the VPC. And from the VPC, if you click here on launch the VPC wizard, will give you this kind of interface, which is a very handy, and I will explain in the minute now what are the differences between the old experience and the new experience. If you don't like to use this experience, you can switch off this button here, and will put you back to the old management console. And you can just say testing, for example, and you submit a feedback. And this is now will give you the Lunch VPC wizard, which is the one we are basically used in many of our labs. So let us create this lab using both configurations. So in the first task here, which is in the first task of the lab, we want to create and to allocate a new Elastic IP. Remember, this Elastic IP is going to be used by our NAT gateway. So I'm going to allocate a new Elastic IP. Click here in allocate. So this IP here, 52.22.155.61, is going to be given to my NAT gateway. If you go back to your VPC wizard, remember that a new VPC experience is switched off. Launch a VPC wizard, select the second tab, and here we are going to put the name lab VPC. Now, based on the lab instruction, we are going to keep the CIDR block, which is 10.0.0.0/24, which are going to give us in each subnet about 251 IP addresses available to be assigned to a virtual machine. Why? Because we have 5 IPs reserved for AWS. I'm going to call this subnet public subnet 1 based on the instruction I have. Select the first availability zone, and the second subnet, which is private subnet 1, is going to be also in the second availability zone, in the first availability zone. And if you click here on Elastic IP, in my case, it's giving me 2 IPs because I have previously have an Elastic IP. In your case, you should see only 1 Elastic IP. I will click on create a VPC. This will take a few minutes for the NAT gateway to become available. So let us wait now. In the next lab tasks, we are going to add to the lab VPC 2 more subnets, one public and one private. And those private and public subnet, we will use them as well and associate them in the route table. So as you can see now, my VPC has been successfully created. And if you go to your VPCs, you will be able to see there is a lab VPC here created. There is also a demo VPC I create previously for another video. And in this lab VPC, you could see in my subnets, if I go to the subnet and now sort them based on the VPC name, you could see in the lab VPC, I have public subnet 1 and the private subnet 1. I need to add 2 more. So I'm going to add, select the right VPC, which is lab VPC, and call this public subnet 2. This is going to be in the second availability zone. And as the lab is specified, we need to give this subnet the IP address 10.0.2.0/24. Then click on create subnet, create another one, and we will select the same lab VPC. And this is a private subnet to second availability zone. And this will take the IP 10.0.3.0/24 and click on create subnet. The next step, after we clear this filter from here, and if you look to your lab VPC subnet by expanding this column to the left or to the right, you can see the lab VPC containing public subnet 1, private subnet 2, public subnet 2, and the private subnet 1. The next step is to go to the route table and associate them. How I know which route table I need to work on? There is lab VPC here, and there is one table with no and one table with yes. So I'm going to select the table with no as main route table. You will find if you go to this route table routes, you will find that this take me to the internet gateway. So this is where I need to associate my public subnet. Click on edit subnet association. You will find this public subnet 1 and public subnet 2 and click on save. Now you could tag this as well by calling it public route table. And you can see I have previously a public route table as well, but look here, the subnet ID, the VPC ID and the tag of the VPC is different from the one I am interested in. And now I need to select the one with main equal yes. If you go to the routes, you can see this is take me to the NAT gateway, which was created by the wizard. Click on this edit name and call this now a private route table and click save. Go to the subnet association, edit and add to it now your private subnet 1 and 2, and click on Save Association. You could verify that you have done the right thing by just expanding this column here and putting the mouse here in the public route table where you can see lab VPC. I can see public subnet 2 and public subnet 1, private subnet 2 and the private subnet 1. All I need to do is just to refresh the console here. The next step, I need to create a security group. So I'm going to create a security group. I will call this security group based on the lab instruction, web security group. And this is to allow HTTP access. Now make sure you are selecting the right VPC ID. If you deselect the default one, which was selected by the wizard, select lab VPC, add a new rule, and this will be the HTTP rule that I'm interested on from anywhere. And click on create a security group. The next task is about launching an EC2. So let us go and launch the EC2 based on the old experience, and then I will show you how to do all of that in the new experience so you can skip to the next part of this video. Launch an instance. This will give me the new experience. You could opt out, and this will put you back to the old experience. Select the first one, which is the next 2 AMI. T2 micro will do. And where I want this, I want it to be in lab VPC in public subnet 2. So this is public subnet 2, and make sure you have auto assign public IP enabled. Now in the user data here, I have a script I need to copy and I need to paste that script here. So hopefully the script is going to be similar to what you can see here in this screen to install Apache Web Server and PHP. And this will download a lab file. It just only to show us that this lab file, we can just use it to test that everything is working, and it will be unzipped into var/www/html, and then we will turn on the web server, check config HTTPD on, service HTTPD start. Add storage, we keep the default. In the tag part, we need to add name, and in the name, I will call this web server. Web server 1. Now in the security group, I need to select an existing one, which is the web security group. Remember that this web security group must be created in the same VPC where I'm going to launch my EC2, review, and launch. This will give me warning about port 22, which I can ignore at this stage. I could create a new key pair. Now in your case, if you are doing my labs, and because you are going to use these, let's call this lab key. And download it to your computer. It will be saved, and save it into your computer because you are going to use it in the coming assignments as well. So keep it in a secure place. I'm going to show you in the next how we can work on it. Launch an instance. So this is pretty much what I have, web server now. And this one, web server, is basically getting an IP address. I could open a new tab and I will be able to see that this web server is getting the website, the demo website that you have we download using wget. You might use the default test page of Apache. It will do, just to demonstrate that this EC2 instance is working as expected. So this is how you launch using the old console wizard. So let's go back to our VPC. And let me choose now another region. If you are using this, if you are doing this lab from a root account, you are okay to use another region for the purpose of this demo. So let me go to California. So we can start from scratch with an empty account, similar to all of you. And this is with the new experience. So I'm going to start from scratch. This is what you will see from your root account. You go to services and you select VPC, or you search for it. Look here, the new VPC experience is active. Launch a VPC wizard, and this will give me the first option, the resources I want to create, which is a VPC subnet. I will call this lab VPC, and the CIDR block is 10.0.0/16. I don't need an IPv6. It will be the default tenancy, which means it's shared hardware, not a dedicated hardware. Now, how many availability zone I need? If you refer back to the lab sheet instruction, I need a 2 availability zone, and I need 2 private subnet with 2 public subnet. I need 1 gateway in 1 AZ. If you are designing highly available system, you can create 1 NAT gateway per availability zone, which means in US West 1A, we will have a NAT gateway, and US West 1B, we will have another NAT gateway. But for this lab, I just keep it 1 in 1AZ. I don't need an S3 gateway, so I will disable this. I could enable DNS hostname, which is basically any EC2 instance launched in this VPC. It will be giving a domain name system based on its name system in that particular VPC. And then if you look here, now it's show you the full details of your VPC creation. You have a lab VPC. It contains in US 1A, public 1, US East 1A, private 1, public 2, private 2. And also it will show you how these are linked with the route table. You can see the lab VPC public subnet is linked with the route table, the public one and the public one containing lab VPC 1 and 2. And the private route table in the first availability zone is linking our private 1 US West 1A. And we have another private route table for the VPC located in US East 1C. So the wizard here created for me or choose 1A and 1C. In the networking connection, I have a lab VPC internet gateway, which is basically enabling all the EC2 instances in the public subnet to access internet. And we have also a NAT gateway, which will enable the private subnets that we have to be able to access the internet for software update and so on. If you choose now 1 per AZ, you will find that there is one NAT gateway in US West 1A and another NAT gateway in US West 1C. I don't think this is necessarily. I can just choose 1 AZ. If you want to stick with the lab, so you want to keep it with the second availability zone to be the 1B, you can change this from here, but also you can just basically keep it to 1C. It doesn't really change the outcome of the lab. Now click on Create a VPC, and this will create the VPC based on the new experience. As you can see now, the VPC creation is completed. So I could view now my VPC, and you will find in the new experience that it has done everything for us. So you don't need to worry too much about the steps. So basically you can do the lab in no time. I have all my subnets available. Now the name and the tag is different because the wizard enforces specific names. You could look also to the route table in the public. You can see the routes. The association is all done. And as we discussed, the private route table for 1A is associating us with a NAT gateway and also link only a private 1 US West 1A, which is a good practice to have a separate route table for each availability zone. It will make our software highly available. Now I could switch to security group and create a web security group. So I'm going to call this web security group. Again, allow HTTP access. Don't forget, delete the default VPC and select your lab VPC. Add a rule, HTTP, and this will be from anywhere, and click on Create Security Group. The next thing, I need to go to our EC2 here. If you can't see it, all you need to do is just to search for it from the search bar, just by typing EC2, and you will have it. It will be very handy as well to add it to your favorite in the new console. So you will have it here in the top bookmark bar here. Now launch the EC2 instance, and this will take me to the new experience of my AWS management console. This is the new update. So I'm going to call this web server 1 based on the lab instruction. It will be Amazon Linux 2. It will be Linux 2 AMI. So these are all the operating system. If I want Windows, you can find it here. If you want Red Hat as well, you can find it here, and so on. So you can find all these different type of machines that suits your need. Even if you want to have more AMIs, you can browse from here. You can see all of them. So for this particular lab, I'm going to choose Amazon Linux 64-bit, T2 Micro. And the key pair here, I don't have a key pair in North California. So let me create a new one. I will call this lab key pair. And just to make it easy for me to remember this, that this is US West region. And by the way, if you are using Mac, similar to what I use, you can download it as a PIM file. If you are using Windows and you need to access via PuTTY, you can download it straight away as a PPK file. If you don't have, or by mistake you download it for PIM file, you can use PuTTY to convert from PIM to PPK. It's straightforward, and the instructions are already available in the course. Create a key pair, and this key pair is downloaded to my computer. Again, keep it safe because we are going to use it in the future. I will keep all these to the default setting. Only I need to change the security group. So in the security group, I could edit here the network setting, and I select the lab VPC, and I want to specify that this should be launched in public subnet 2. I want to enable auto assign public IP. I want to select an existing security group, which is the web security group I created. You could also get an advanced network configuration, which we don't need at this step. You could also look to advanced details like the host name, the instance profile, if there is any permission needed, and so on. And here where you can find the user data. Again, you can copy the script available in the instruction and paste it as it is here. This is the right script, and any script of these labs will work, guys. Any script that is available in lab 2, lab 3, or lab 4, they will work, because this is all we need is to download this lab app.zip file, and we put it in var www.html just to see a web page, a testing lab application. Click on launch an EC2 instance, and this will launch your EC2 instance, as you can see here in North California. Don't forget that. We will wait for this guy to become running and available. Open a new tab and paste the IP address of the new EC2 instance. So at this stage, guys, you could just keep the setup here so you can carry on and do the rest of the assignments that we have. So for example, you could move now to the next assignment, which is the one which is Introduction to Amazon EC2 Instance. The next step, or the next lab, which is Introduction to Amazon EC2, let us switch back to North Virginia. We want to launch an EC2 instance in the lab VPC. So before you can start this lab, you need to go to your VPC and check that you have the VPC created here, which is lab VPC. If you don't, then you need to create it based on the previous lab instruction, whether in the new VPC experience or in the old VPC experience. Remember, the VPC ID and the subnet ID are the most important. The tags, they are not really make any difference because they are not used to link the VPC with the subnet. Tags are only for us just to give us information about the resources we created. So I will go back to my EC2. I am here in North Virginia, and I will launch an EC2 instance. I will select the first one. Again, this is the old experience. You could switch to the new experience, and it will be relatively the same. So I'm going to show you both. So in the next here, I'm going to select lab VPC, public subnet 2, and auto assign enable, and copy now from lab 3, Introduction to Amazon EC2, copy the script. And the reason why I put this script, because this script we are going to use in lab 5 when we build our RDS. So this is more suited for lab 5, as you can see, which is the RDS lab. Add storage, add tags. I'm going to call this name here, and I will call this, will be lab 3 web server. So you can distinguish this one between the resources I created for lab 2. Configure security group. In the security group, we are going to configure a new security group. We will call it, create a new security group. Let me call it web security group lab 3, just to show you. You could use the previous security group that we created in lab 2. There is nothing prevent you from doing that, because it will give you the ability to allow HTTP to your EC2. It is the same. It will have the same impact. I'm going to select HTTP. I will deselect SSH. Remember, when you go to lab 4, you need to have SSH enabled so you can access the EC2 instance and launch. I will use lab key to make my life is easier, because I have lab key downloaded to my computer. Again, you can download it as a PPK file or convert it to PPK file for Windows so you can access via PuTTY. I'll launch the EC2 instance. So this is basically what you need to do in Lab 3. Once this EC2 instance is running, which is Lab 3 web server, we need to do a few things. We need to go to the monitoring tab, but we need to wait for the check. So let us wait for this to be fully loaded. So now my EC2 instance is running in the status check is still not available for me. So I could refresh, still initializing. So I need to wait a bit of more to get more data from the monitoring tab. So we can see there is no data available yet. So we need to wait for this status. There is 2 checks. We need to wait for them. So as you can see now, the lab is ready. I have the EC2 instance, which passed the 2 out of 2 check. Now in the task, we want to monitor the EC2. So we need to select it from the checkbox here, and we need to go to the monitoring tab. So this is now our monitoring tab. You could also go and see the monitoring and the troubleshoot from the action menu. This is monitor and troubleshoot, and we want to get the system logs. So you can see here, these are the system logs that are available to us to review, which can tell us exactly what happened, what kind of software installed, what are the most recent update happened in terms of installing PHP based on my user data script. And also we need to find out where we install Apache server. So if you scroll up, it should be before PHP. So you can see the HTTPD was installed in this EC2 instance. So we can also get an instance screenshot. Sometimes you need to share this and basically share it with your team, or you want to get, for example, a download from these logs, or you copy them. Sometimes you need to send them to AWS for troubleshooting and so on. You could also select that lab web server, and from action menu, from the monitor and troubleshoot, you could also get a screenshot from your EC2 instance, and you can download it to your computer and you can save it as well. So I can download it, as you can see here, as a JPG image. You could also update a security group. So in this particular lab, we are going to enable HTTP, which I did enable before. I could show you as well the process. So you go to security tab, and this is your security group, and you can edit the inbound rule. And there is HTTP here. So I'm going to add SSH. Any modification, whether you follow the lab instruction or you follow the video, both are going to take you to the same result. We need to resize this EC2 instance. So I can go to my Lab 3 web server. You can ignore all of these guys. It's nothing related to this lab. Lab 3 web server is the one I'm interested on. So I go to instance state, and I need to change the instance type. So I'm going to stop it completely. So clear the filter, and I'm interested in this instance here, which is the one which is stopped. I could wait for this instance to be fully stopped before I can do any changes to it. Now it is stopped, so I could go to action, instance setting, change instance type, and based on the lab instruction, we want to change this to T2 small. So I'm going to select T2 small here and apply. The instance needs to be fully stopped before you can do this action. We want also to change the volume, so we are going to go to volumes, and you can see I have multiple volumes here. If you do proper tagging, you will find that Lab 3 web server is tagged here. But what if I forget to tag? If you scroll to the right, this will give you the attached instance. So you will be very sure that this is Lab 3, or you can verify based on the instance ID in order to change the volume. I can go to action now from this volume and modify the volume. I need to increase it to, for example, 10 gigabyte, just to show you how you can do this. Because sometimes you run out of space and you need to expand the volume. You could go back to your instances and Lab 3 web server and click on Start Instance. You could also go to the limits of your EC2 instance and see what are the limit per region for this account. Now, if you have a root account similar to myself here, you can see the Lunch configuration. You can have 200 Lunch configurations, 200 auto-scaling. You could search, for example, how many EC2 instances I could create, or for example, how many load balancing. I am allowed to create 50 load balancer. And these are the kind of things they will ask normally in the exam. how much, for example, running instances I could have. I could have 20 reserved instances, 8 security group per instance. I could have the maximum on demand is 384 virtual CPUs, and so on. The next thing is you can also look to spot instances, and these are not available only, they are available for root accounts. So if you're using any AWS Educate account, or if you're using AWS Academy account, you won't be able to access those kind of details. The spot request, this will give you the price history. So normally in this particular region, C3 large, let us select, for example, T2 micro. You can see that this on-demand price is 0.0116. The US East, you can get a spot instance for 0.035. So you can save about 69.83% of the spot instances if this is a Linux operating system. If you're looking for a spot instances with Windows, then you are going to look to a 0081. Now remember, for Windows, it's billed per hour. For Linux, it's billed per second. You can also display a normalized price per month, and this will give you the best price, so you can know exactly when you want to bid and what is the price that you can get, the cheapest price you can get for that spot instance. So this is pretty much what you could do in order to finish Lab 3. The last thing is shutdown protection or termination protection. You could enable this by going to the instance setting. You have, or you can change termination protection by doing enable and click save. And if I select Lab 3 web server, this will prevent your colleagues or your teammate from terminating the instance accidentally. So this will give them a warning. If you want to terminate it, change the setting and disable termination protection, and then you need to terminate. If you have the new console experience, it's going to be the same. It will be much easier. You launch an EC2 and then you change to the new experience. All you need to do is web server, and you can do all the settings that you need. My AMI, for example, if you have a specific AMI, there is also recent one, and the quick start, Windows, Linux. This is going to be T2 micro. Select the key pair. Let me call this lab key, okay? And then you need to allow a specific security group. You click on edit, or you create a new one, depending on your need. In my case here, I want it to be in lab VPC. I want it to be in public subnet 2, not private subnet 2. I could create security group, and in this security group, based on the lab instruction, I want to enable SSH only, and later on I need to modify it. It will be all the same, and I will paste as well here the script that I copy from the lab sheet. So with the new console experience, you can find everything you need in this Lunch configuration, all in one place, not multiple windows like before. It's much easier, much handy to launch an EC2 instance, and then you click on the launch. So this is pretty much what you need to do for Lab 3, and then you continue. The process for action, monitoring, getting system logs, it is the same. The only difference is how we can launch an EC2 instance between the old and the new experience. Now in Lab 4, guys, you are supposed to have in your EC2 instance, you are supposed to have a Lab EC2 instance, which is similar to what we have here. So you are supposed to have one EC2 instance, which is the web server that we created in Lab 3. And in Lab 4, we are going just to connect to this EC2 instance, and we want to mount to it an elastic block storage volume, and we will save some data in it, and then we will restore the data from the snapshot. So let me show you what you need to do in Lab 4 working with EBS in assignment number 6. So in assignment number 6, working with EBS, the first thing I need to do is to make sure I have the web server experience, or the web server, in your case, it should be web server 1 running with also the EC2 instances that we created in Lab 2 and Lab 3. It basically, each lab is building on the previous lab. So each assignment is built in top of the previous assignment. So let me call this now, just to make it easy and similar to your lab instruction. Let me rename it as lab. You can just do this. And now from the availability zone, I could see that this one is available in US East 1B in the second availability zone, or 1A doesn't really make any difference, guys, for your case. So for Lab 3, I assume that you have an EC2 instance running, that the one we did in Lab 2 or Lab 3 is called web server with public IP address. And in this particular lab, we are going to create an elastic block storage volume. We will attach it to this EC2 instance here. So you need to make sure that the security group that you have is going to enable SSH. So I'm going to do this just right now. SSH enable. So edit, add an SSH. You could do also this later in a later step. And this will be anywhere and save. Now, how you will know which key pair is working with this EC2 instance? If you select it and you go down to the details, you will find that this EC2 instance is launched in Lab VPC, the one I create with the wizard, and it is associated with a key pair, which is the key pair I create, Lab key pair US West. So you should have this key pair there in your computer. If you lost it, delete this machine and run and launch a new one. And this is the point of creating an on-demand EC2 instance. Now, this Lab 2 key pair in US West, I have it here downloaded to my download folder. All I need to do is to have access to it in order to access the EC2 instance in the cloud. So let us go and start working on the lab instruction. So we are going to create a new elastic block storage volume. So from the left, we are going to go to the volumes, create a new one. And this new volume, I need to give it the size 1 gigabyte because this will save our cost while doing this lab. I want it to remember in US West 1A, 1C. So I want the volume in 1C. As you can see, I find out the availability zone by just selecting the EC2 instance or by navigating into the details. Let me go back to my volumes now, create a new volume, 1 gigabyte, and this will be in 1C, and create a volume. The next step, after you create this volume, is to attach it to the EC2 instance. So I'm going to select it, select the volume, go to action, and then this will be attached. Now the volume is still in creation, now it's available. So I need to wait until I see available here. So select it again, action, attach, and this will give me all the available EC2 instances I have. You can see the web server tag is there, and attach. So the volume is attached. Now we want to connect to the EC2 instance from the cloud. So let us do this, and let me show you how you do this from Windows, because most of the students are using Windows. So this is your laptop. Imagine that this is your laptop, and we managed to have the key lab key pair.uswest.pem file in our desktop, and we need to connect to the EC2 instance in the cloud. What we need to do? The first thing you need to do, guys, is to go to the Google and download PuTTY. So PuTTY is a software that we use for SSH. PuTTY download, and this will take you to the PuTTY page, and you can download it from here. Click here, and this will download the 64-bit x86 and download, and this will run the installation as usual. Just click on it when it's fully downloaded, and there is also different copy of Windows Installer MSI for your framework and for your operating system. So PuTTY is downloaded. All I need to do is to open it and run. Just as a similar Windows software I need to install. I have PuTTY already installed in this machine, so I'm going to click on cancel. You can just carry on with next, 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 and so on. Now, what are the steps needed in order to connect to our EC2 instance? You need the key pair, but this key pair, as you can see, is PIM file. So I need to change it to PPK. So the first thing I need to do is to search in, after I install PuTTY, for something called PuTTyGen. PuTTyGen is a software, comes with PuTTY. If you don't have it, you can download it again from the installer. Go back to the page and look for PuTTyGen. To my computer, it's ready. Open it, and this will install PuTTY generation in my computer. If you are good enough, you will be able to download, when you create the EC2 instance, you will be able to create and download the key pair as a PPK file. So you don't need to use PuTTyGen. Now I'm going to open my private key from my desktop, and this key will be converted from PIM file. So I need to select here all files and select the lab key pair, load it. Once it's loaded, only now click on Save Private Key. So this will be saved, and it will be giving the same name. You can call it the same name, which is lab key US West, and save. So if you go to your desktop now, you will find there is a lab key PPK file created for me. The next step for me is to go and connect to my EC2 instance. So if I go now to let me put these side by side so you can imagine that this is your laptop and this is your AWS console. I'm going to instances, web server. All you need to do is to copy the IP address, and I need to go back to my EC2 instance or my laptop where PuTTY is available. I need to put the IP address of the server that I want to connect. You could also save this as a session later on, so you don't need to configure it again and again. It is also good practice to put before the IP EC2, which is the default username for a Linux machine, for a Linux AMI, EC2 user at the IP address at port 22. Make sure you have open port 22 in that machine. And now in the connection, I need to increase the time to live to 30 seconds to keep the session between PuTTY and your EC2 instance alive. From the SSH now, I need to expand it via the tree here. Click on auth, and now load the private key, which is the one I just generate using PuTTYgen. Click open. You already know everything is okay. Click on open, and this should allow you to access the EC2 instance in the cloud. Click on accept. So now I am inside the EC2 instance. I could verify this by looking to the IP address, the private IP address. You could go back and you see that this is the IP address 10.0.23.82. So this is the same IP address I'm using. So what are the steps that I need to do now? I have mounted the volume into this EC2 instance. And the next step is basically to make sure that I can access it. So I need to put the first command, which is df-h, which show me the available storage in this instance. And you will see that there is the dev/xvda1 with 8 gigabytes. This is the root volume that we just created. Okay. The next step now, I want to create an ext3 file system on the new volume, which is in the /dev/sdf. Okay. The /dev/sdf, this will make a file system. So I need to copy the command and paste it here with right click in PuTTY. So this will create the file system. Now let us make a directory using the command sudo mkdir in the mnt, the mount point, and I will call this data-store. Now I need to go and mount the new volume to this folder, which is the data.store. So I need to put this command, sudo. Sudo means run the command as a super user. Mount. The volume was attached to this EC2 instance as /dev/sdf/ now I need to mount it to my mount folder, which is mnt/data-store. So at this stage, I should be able to get the correct information about the volume. So I could, for example, do cat to verify the configuration is successfully, etc. And this go to the file system table to view it. And you can see here the result of this command. If you put the df command -h to view the available storage again, you will find now there is a new volume attached, which is the one in /dev-xvdf and the 1 gigabyte, which is mounted to data-store. Let us put some data on the volume. So let us create a small file in that folder. So in the lab sheet, they give you like a simple command. So let me just make it easier for you. Let us go cd, call directory, mnt/data-store. Okay. And if you put ls here, list, you will see that there is no file. So I'm going to create a new file. I could use the command sudo touch in Linux to create a file called file.txt. And I could open it using an editor like nano file.txt. And I will say, this is my test file for the Elastic Block Storage lab. Now, Control X and save. So I have now some files in the volume because it is inside the folder MNT, data store, and so on. Now the lab sheet is telling you to put this command, which is do the same. This will basically create, if you copy that command from the lab sheet, this is mainly will copy, put some text into MNT data store / file.txt. So it will have the same impact. I could change this to file1 just to show you. So I don't want to overwrite the file that I just created manually. And if you do ls now, you have two files, file1 and file.txt. Now I could view the content using the command that I have, which is, so I could see the content of file.txt. I could see the content using the cat command file1.txt as well. Now the next step we need to do is to go to the management console. And from the management console, guys, I need to create a snapshot. So I need to go to volumes. And from the volumes now, I need to select the volume with 1 GB, and I will create a snapshot. I will call this snapshot my snapshot, and create a snapshot. Now this snapshot will be available in this tab here. Now it is in pending state, so I'm going to wait for it to be available. In the next step now, we need to go back to our POTI connection to the EC2, and we need to delete the files that we just created. So you could do this command, sudo rm, to remove the file.txt. If you do ls now, you don't find that file.1. I could also delete the second file. Imagine that these are like a very important application data and we lost them. We lost them by accidental deletion or any sort of things that happened. Now let us go back to our management console now. And in the management console, I could see now that the snapshot is already created for me. So what I need to do in order to restore the content of that snapshot, which was a point of time snapshot, to my EC2 instance. In order to do so, I need to select that snapshot. So I go to the left here, snapshot, select, and then from the action menu, I need to create a volume from that snapshot. Now I need to select the availability zone where I need to create that volume, which will be, in our case, US West 1C. In your case, if you are following the lab instruction, it will be US East 1A, depending on where you have your EC2 instance created. Click on create a volume. Now this volume, you will find it available here in US West 1C. Okay. Let me tag this as my restored volume and click save. What I need to do next, I need to basically attach this volume to my EC2 instance. So let us go to action now, and I will attach a volume, and this will give me all available EC2 instances, which is the one I'm looking for, which is web server. And look here, the mounting is going to happen into /dev/sdg, and this is the device identifier where our volume will be available. So we choose attach volume, and now this volume is attached. Let us go back now to POTI, to our connection to POTI, in order to see how we can mount it again into another folder. So I'm going to do it in the old way. cd, let us go back to the home directory, cd. So if you want to go back, so make sure you are in the root. So this will be cd EC2 user. So here I am in the home with EC2 user. All right, so now I need to mount it. Let me clear the screen so you can have a better view of this. I need to create another folder. So sudo mkdir, and this will be a folder I will create in the mnt /data-store2. Then now I need to mount it. So I will go sudo mount, the same command we used before. Remember, the volume I just attached to this EC2 instance was attached to the device ID /dev/sdg QG, SDG, and now I want to mount that volume to /mnt data dash store 2. Now, if you go to that folder, which is /cdmnt /data, by the way, you can press tab in Linux and this will do the autofill. So now I am in data dash store 2. If you put ls here, you will find file1.txt, file.txt. You can also view the content of file1 or file.txt. So this is basically the content of my files are restored. Remember, if you go now to the previous folder, in the MNT, I have folder data store 1 and data store 2. In data store, I still have no data because I delete them. So there is no content here. So this is pretty much what you need to do for this lab. So in lab 5, guys, we already have a lab VPC. So at this stage, you should already create in the previous lab the VPC, and we have a public subnet 1 and 2, private subnet 1 and 2, and we have a web server with a security group. And in this lab, in particular, we are going to create an RDS, and we will test our connection from this web server to the RDS. So let us look how we can do that. So the first step in this particular lab is to go and create a security group for our DB. So to create a security group, you go to the EC2 or to the VPCs. Both, they will take you to the same thing. So we go to security group, create a security group. I will call this DB security group, allow access to RDS from web server. Now make sure, allow access to RDS from the web server. Make sure to delete the default VPC and select lab VPC. Add a rule, and in this rule, I want to enable connection, which is Aurora, which is the right port for our lab. So this is MySQL Aurora, and in the custom here, I want to make sure that only I accept traffic from the web security group. So here, if you put custom and you put SG, this will give you the web security group, or search for it, or even go back to your EC2 instance to verify which EC2 group you are using. So if I go here to my web server, I could go to the security, and this is the security group I'm using. I could copy the ID if I can't find it by name, and by just putting the ID here, pasting the ID, you will be getting the right security group. And then create a security group. In the next step, we need to create a DB subnet group, and this will take us to RDS. So from services, look for RDS. And in the RDS, because we are using our root account, we want to make sure that we have a subnet group first before we create an RDS. So we need to go to subnet group, and now we need to create a DB subnet group. I will call this a DB subnet dash group, and this is, again, the description is mandatory, it's required, so you can't leave it blank. So let us put the same DB subnet group. Now this will be in the lab VPC, and in which availability zone, I want it to be US West 1A and 1C, because this is what happened to me when I use the VPC wizard in the new console, in the new management console. It gives me availability zone 1A and 1C in North California. Now, the lab sheet is doing it in North Virginia, but my North Virginia, we use it just for demonstration of the old console, and this in North California for the new one. Now, in US West 1C, I need to mount this to my private subnet. And this is where the challenge happened. For most students, this is where make mistake. You need to make sure you are selecting the right subnet, which are the private one. You could go back to another tab to your VPC, and from that VPC, you need to select the subnets in lab VPC, okay? And I want to get the tag or the ID of private subnet 1 and the private subnet 2. So I could copy the subnet ID and I could save it in a text editor or in a note. In my case here, I want to save it in a text editor. So just to show you guys. So this is the first subnet ID. Let me copy. And this is the second subnet ID, and I will paste it. Let us go back to the subnet group, and based on the lab instruction, The one which is 773 is my first private subnet in US West 1A. And the second one is the FFD, which is this guy here. And once you select them, you can verify as well using the CIDR block that was allocated to the subnet by the wizard. Create a subnet, a group. In the next step, we need to create an RDS. So you go to the database, create a database, and this, remember, will be a multi-AZ deployment. So we are going to switch to a new database creation flow, which is the easy create, select MySQL, select a free tier, and the database identifier will be lab-db. This is the name of the EC2 instance, guys. It's not the name of the DB. And the master username will be called main, and the password, it will be lab-password, which what we use normally for these labs. Just a simple password because we are going to clean all of these once we finish. Now the DB instances, classes, and all of these details, you can see them in the easy create. You could go to the standard create if you are interested to get more information similar to the lab sheet. So this is a free tier again. Now the DB classes, we are asked to select the T classes, and this will be T2 micro. If you can see T2 micro, you can just enable this, include previous generation classes, and this allocated storage will be 20. Enable storage auto scaling. I don't think it is necessary, and we will make sure now, because this is a free tier, I can't create multi-AZ deployment. If you have div and test, you will find this option here is active. You can create a standby instance in the second availability zone based on the instruction we get from the DB security group. So if you check now, you could see now I need in the connectivity to make sure I'm going to launch this in lab VPC, and this is my subnet group. I don't need a public access. I want to choose an existing security group. This is another thing, another mistake most students do. When they choose existing security group, they keep the default one. So you need to disable it and you select the DB security group. Now in the additional configuration, we want to make sure that the port is a 3306, password authentication. Additional configuration, what is the database name? It's going to be lab. So this will create a database. Once the EC2 instance is created, there will be a database called lab. There is no need to automate backup and encryption and performance insight and enhanced monitoring, because these all come with an extra cost. So at the end, it will give me the total cost for this EC2 instance per month. So make sure you delete this EC2 instance or the RDS once you finish this lab. There is no need to pay for this demo, for this particular lab. You don't need to pay $126. So make sure to wipe it out, delete it by selecting it once it's available, and from the action, select delete. All we need to do is to wait for this EC2 instance to be, for this RDS to be ready. And once it's ready, we are going to go to our EC2 instance, which is the one we have in US West here with our demo website. So I'm going to select this instance here. So I have it here, and you can see in this page, we have something called RDS, and this is where we put the RDS endpoint, database, username, and password, and we will click on subnet in order to make sure that we can connect to the RDS by this kind of test page. So let me go now to the RDS, and I will see that this is still in creation, and normally it will take a couple of minutes because this will create a DB in the first availability zone and in the second availability zone. So let us wait for this, guys, to become available. So the RDS is this one here with DB T2 micro, guys. Copy the endpoint. The database name, if you look to the configuration, is called lab. Username is main. You could also verify it is main, and lab-password. So I can see I have successfully connected to the RDS. So I could add a contact test me at me, for example, and submit. So I could add, remove record from the RDS, and this is basically working as expected. Lab 6, guys, we are going to create a load balancer and autoscaler. So the starting point for this lab, you should be able to have this architecture by now. After you do all the assignments, you should have a web server and a multi-easy deployment of RDS. If not, you could start from scratch, build the VPC with all the subnets, launch a web server using the script that we have in the lab sheet, and create an RDS similar to what we did in lab 5. So if you are in this point, you could carry on to the steps in this lab. In this lab, we are going to do two things. We create a load balancer, application load balancer, and autoscaler, and we will move our web server to the private subnet so it can speak with the RDS. So I have in this particular lab, we have web server 1 and the VPC as well. You should have lab VPC or similar setup depending on which console experience you are using. So this is lab VPC, and we have 4 subnet, public 1, public 2, private 1, private 2 as well, and security group, which are the DB security group and the web security group. So mainly in this lab, guys, we are going to create a load balancer, and we will create a lunch configuration and an autoscaler. So the first step as well, if you have the RDS as well, and you did lab 5, in your RDS, you should have an RDS with dbt2 macro. You can ignore this one because I'm going to delete it now. I don't want to create a snapshot. I will show you also how to delete, so you save a lot of money and you don't keep resources running in the background. So I'm going to delete this dbm6g because this will be a very expensive one. And this will delete the primary node and the standby node. However, while I'm doing this lab, I'm interested in this RDS, which is in lab VPC with this DB security group and this DB subnet group. So the first step, I need to go to the EC2 instance. And in my EC2, I have a web server. It's fully functional. I could verify this by opening a new tab, putting the IP address. It is fully functional, all good. So what I need to do, I need to go to action, create an AMI, an image, and I will call this web server AMI. It is a lab AMI for web server, and then click on create. Now this will take a few minutes. This will create an AMI and it will appear here on the left. This is the new AMI, is still in pending state. So I could proceed to the next step by creating a load balancer. So I go to the load balancer and click on create load balancer. Select the application load balancer, create, and I will call this load balancer lab ELB. It will be internet facing because as you can see from the lab diagram, this should operate in public subnet 1 and public subnet 2. And here I need to select in lab VPC, and I want to operate at US East 1C, US West 1A and 1C. This should be public. Make sure these are public here, guys. And here I need to create a new security group for the load balancer. So the security group, I'm going to create an ELB security group, which allow access to ELB. Delete the default VPC, select the VPC you are interested on, and make this HTTP open to anywhere, and click on create security group. Now go back to the load balancer, refresh the page. You will be able to see the new security group, ELB security group. Make sure to delete the default security group, and this will be a listening to port 80, but you don't have a target group. So you need to click here and create target group. This will open a new tab. So your target group is a couple of instances because this is an application load balancer. If you are creating a load balancer for container application, like Docker containers, you could use IP addresses. If you are creating a network load balancer, you can route traffic at layer 4 for TCP as well. So the target group is going to be called lab group. And in this lab group, it will be in lab VPC. It will listen to HTTP 1. And the health check is going to be /. So there is nothing really distinguished about these. You could change the threshold just to get a better and quick response from the target group, but I will keep everything to the default and click next and create a target group. So I have now my target group. I need to go back to my load balancer, refresh this page and select lab group and create a load balancer. At this stage, if you go to the AMI, you should be able to see that the AMI is ready, available. So I could proceed to the next step where I need to create a launch configuration. Where you find the launch configuration is below in the auto scaling. Create a launch configuration. You could call this lab config. And the AMI, it will be my AMI, which is this web server AMI. The instance type, you can choose it from the list here, which is T2 micro, because it's a free tier. Remember, guys, after you finish this lab, you need to delete all these resources. And in the next step here, I need to select an existing security group. My AMI, because these are EC2 instances, they will be serving my web server, so it will be taking the web security group. I don't need a key pair and create a launch configuration. You could proceed without a key pair, or you can just pass the same key pair that we create in the previous. So my lab configuration is ready. Now I need to create an autoscaler. To create an autoscaling group, create an autoscaling group. Now by default, this will give you the launch template, but in this lab we are using the launch configuration. So I'm going to call this autoscaler, and the lab config is there. Give me details about it and click next. This will launch my autoscaled EC2 instances in lab VPC, and I want them to be launched in the private subnet 1 and the private subnet 2, because this will be a private web server. Click next. I have an load balancer, so I need to select attach to an existing load balancer, and this load balancer is a target group is called lab group. I could also get the health check from the load balancer here. Now in the next step, I enable group metrics, because this will collect all the data from all EC2 instances as a group, and click on next. The desired capacity is 2, the minimum is 1, and the maximum is 6. And I could also make a target policy scaling policy, which basically will monitor a specific metric with a specific threshold. And this will be basically next, and click next, and click next, and then click on create. Now, once you create this and you go to the autoscaler and you look to the activity, you will start to see the autoscaler is basically running and creating a new EC2 instance. You could verify this by going to the EC2 instances that you have, and you can see now there is a new EC2 instances that start to appear here with a pending state. At this stage, you could turn off or stop the existing web server, because I don't use it to operate in public subnet. We could later on test that we are seeing a correct data from those autos group. Now, mainly here, my autoscaler is successfully create for me 2 EC2 instances, and that can be verified by going to the activity, successfully launch a new EC2. And you could also look to monitoring, instance management, and many things. Now, you notice here in my case, I forget to do the tag for those EC2 instances. So you could basically go and edit by adding tag and call name. So if you forget something, you could go and edit that, and let's call them auto web server and update. Will basically update all the EC2 instances that I have. Now, this is where most students lose patience and make mistakes. The next step is to take the load balancer that you create, and from the load balancer, you have a public DNS name. Let me expand this up to and that's the public DNS name you are interested on, and you need to copy that into a new tab. Most likely your load balancer at the first 5 to 10 minutes, it will give you service not available, but in my case, it's very successful. Why? Because I give it enough time to converge. I give all my autoscaler EC2 instances a good time so they can create it, run, and they are in status checked. Most students, they rush this step and they start to get error here, so they lose faith and they think they make mistake, but you did not. All you need to do is to wait for a couple of minutes. You could load the test, and this will load the CPU, like run a script at the background of your EC2 instances to make your EC2 experience high CPU threshold, and this will trigger now your auto scaler. So if you go to your autoscaler, you will start to see more EC2 instances will be run and created in response to the test load that you add. You could also share this to your friend. You could open it from a different browser or a different target just to give it more a test and more a threshold. Remember, to do all of that, make sure to delete everything you create at these steps. So let us now wait for the steps and the threshold for the CPU load to be triggered. And to monitor this, you could go to the CloudWatch. So let me go from here to CloudWatch. And from your CloudWatch, you will start to see an alarm raised because there is a new data. You can see there is one alarm in check, which gives me that the target scaling group I create in OK, which means the CPU utilization is below 60. It's not reaching 60 yet, but still start to pick more load. So let me put more data as well. So let me open the load balancer link from multiple web browsers. So you can have Edge, Chrome, Firefox, and load the test. This will put more pressure in your EC2 instances. So let us put more pressure. And this will be obvious here in a CloudWatch, where you can see now the CPU from the group is reaching about 14%. And if you go to the target group of your autoscaler, you will see that there is more EC2 coming and created in response to more CPU load. Let us wait a few minutes for the test to put the CPU above 60. So you can see the script is auto-loaded. So just keep putting pressure on this. By the way, you could open the same thing from an incognito window. So private session will do as well, just to make multiple sessions to our load balancer and create multiple tests. Or from another web browser like Firefox and Edge and so on. So we are getting more data now. And you will, in a few minutes, you will start to see that you are getting a high alarm state. You can see here the CPU alarm for low CPU metrics. It's insufficient data, which means the CPU is still below 54, but there is no enough data point. And that's why we need to wait for long period of time. So for high CPU alarm, we wait for 3 minutes. For low CPU, wait for 15 minutes. It is very important because this will prevent resource thrashing in our autoscaler. You can see now the points start to pick 87. So if you go to your EC2 instances, autoscaler, or to the instances itself, you will be able to see that there is more EC2 will be generated and created for the autoscaler to meet the demand for high CPU. So the desired capacity now changed to 3, and the current now is 2. So basically, based on the current threshold, if you look to the activity, there is a new EC2 now just launched to meet the new CPU demand. And this will keep creating EC2s all the way up to 6 EC2 instances. And now you can see I am in alarm that I have a high CPU. So this is pretty much what you need to do for this assignment. Thank you for seeing this video and see you in the next one.